Welcome to MILO. MILO stands for Machine Intelligence Learning Optimizer, and thank you for listening to this very short but very informative presentation. I'd like to make some basic disclosures. MILO is a University of California intellectual property, and as a product of the University of California, it's now led to the University of California partnership, in which MILO-ML LLC is a part of. Our background within machine learning is extensive, but also quite a bit of a background in software engineering and other relevant aspects within this space, which had made all of this possible. So special thanks to 30 plus investigator friends and colleagues who've made all of this possible, and MILO the success that has been up to this point. There's some basic facts around machine learning. Artificial intelligence machine learning is very powerful, but when you see these kinds of algorithms, even when we remove the mathematics out of it, it's foreign to most people. So it's hard to know where they can actually start within this discipline. So the current challenges with the machine learning, as discussed, is that it could be very intimidating because it requires typically a team with machine learning, statistics, and programming expertise. It can be very time consuming and not easily accessible either. And that part we know firsthand, where some of these studies, you have to meet with multiple different teams from various aspects of machine learning disciplines or data science disciplines. And so that could actually by itself take months to do. And then finally, even if you actually build something that's worthwhile deploying, many of the models that we actually do build, and this one I know firsthand, is they actually are fantastic models that are published in literature, but they don't actually become deployed or become an actual products to use. And that could be because of multiple reasons, for medical legal reasons, but also a lot of it has to do with resource reasons, where we may not have the right resource to be able to deploy the model because you've built the thing in Python and now you want to deploy it in another language as a user interface, and you may not have the expertise up front to do it. So now imagine a world where you can address all of those issues, where you could do machine learning and AI studies, and it'll be as easy as using your website on your laptop or even your smartphone, where no machine learning expertise will be needed, no software engineering expertise needed whatsoever, basically no coding or programming required. It's just easy to do and plain. Our solution was MILO, and MILO basically allows anyone, any investigator, to have access to these AI/ML tools, and with no coding, no programming, and no machine learning expertise. All the heavy lifting is done by MILO. It's basically your virtual data science and software engineering team, all as a package at your fingertips. Its key highlights is that it expedites the machine learning process dramatically, as I'll show you in a second, of how much faster it would actually work compared to your traditional approaches. And this is where the proprietary aspects comes into play in terms of outperforming your traditional approaches, but even actually outperforming some of the other AutoML approaches that are out there. And finally, it's a very user-friendly interface that is actually deploys, in which anybody can actually understand what comes out of MILO. So you can communicate within your team easily, and quite frankly, you can publish them, use them for your own quality studies, whatever basically serves your need. This is what I meant when I'm talking about, expediting the process in terms of how much faster it will do. These are two separate IPs that we've had that were outside of MILO, actually. One was on an acute kidney injury predictor model that actually took our team about 4 months to build. And we were questioning, see if MILO could have actually done the same thing. And interesting thing is that it did, and it did it in less than a day. So the same work that took us several months to do, MILO was able to do it in less than 1 day. And the same thing with our burn sepsis model. Again, something that took us 4 months to build and optimize, we were able to find the best optimal model that was ready to use in less than a day. And these are published, obviously, and feel free to read more about the details about this. But to give you a little insight about one of them, this one specifically happens to be the burn sepsis model. As you can see, lots of models were generated without MILO initially, And we were excited because we found a model that was performing extremely well. And at this point, we were questioning, now that we have this, could Milo have found that same model? And the answer was, it did. It found that same model, but obviously it had to build 6 times the number of models that the original study did. But most importantly, it did all of this in less than 1 day, rather than the 4 months that we did initially. But because we also have built so many additional models, you can imagine just intuitively and statistically that there could be additional models in the background that could even outperform that top one. And not surprisingly, we did. We had found 5 additional ones that actually outperformed that top one. And by the way, what I'm showing you here is not unique to just our burn sepsis study, but it actually has been seen in other studies that we've done as well. And you can see that from the publication. And these are various other publications, and just showing you this in terms of the diversity of the studies that have been done within Milo and published within peer-reviewed journals. And they're within, various disciplines: sepsis, acute kidney injury, COVID testing platform, tuberculosis, kidney transplant, you name it. So basically it's there. And most importantly, Milo is a validated platform that was initially validated on about 11 IRB studies. And now it's been studied in over 20 of them, but they're from various aspects of medicine, and even some slightly outside of medicine. And as you can see right here, some of these studies that were done with Milo were on burn surgery, trauma surgery, transplantation surgery, but also outside of surgery in internal medicine, cardiology, or infectious disease, or global health studies in tuberculosis, or even a testing platform build, like our MALDI study with COVID testing platform that's in the works right now. And then certain other things like our Amazon synthetic data study, and even a COVID hospital day predictor study. But besides all of these, we actually were able to show that you could actually also, build models that are outside of medicine. So there's some agnostic features to this platform as well. And so the step 1 predictor is a good example of it, where these are models that we have built for the medical school, in which the students who are at risk of not passing their national exam are identified early on, and you could actually intervene sooner as an administrative team. So one of them says early, and the other one is late. Early meaning that we could identify them about 1.5 years or 2 years before they're taking the exam, and the late is that they're identified about 6 months or 3 to 6 months before the exam, so they can get additional time to study more. Anyways, lots of things and lots of possibilities to do, as you can see. Ultimately, this is how Milo works. It makes no assumptions about your data set. As somebody who's been in this world for 20 plus years, I can tell you that whoever the experts within this world, they all have biases, including myself. And so that part we already know. So if you came up with your data set and your study to any of us, and if you brought it to me, I may say, based on my own experiences, the best thing for your model may be a neural network. If you brought it up to another machine learning expert, they may say, no, the best thing for that might be a random forest. And who knows? And the third one may say something different. Maybe a parametric logistic regression algorithm might be the best way to go. And who knows who's right? So instead of having a machine learning data science team or data science expert deciding what's best for your data set or your study, we let your data set decide what's best for it through Milo. So as you can see in that red block, Milo really becomes more like a matchmaker between your data set and the algorithm / the models that ultimately serve your need. And most importantly, it follows ChrisDM approach, and actually it's an enhanced version of ChrisDM, the cross-industry standard protocol for data mining approach. And because we're dealing mostly within the healthcare space in small to intermediate sized data sets, it was very important for us to make sure that we've developed a study design that actually addresses the possibility of overfitted models. So with our enhanced ChrisDM approach, where we actually require a minimum of 2 data sets that are included. So this way you have 2 separate testing platforms. That way you're actually minimizing the possibility of overfitted models. And that's an important thing within our space, as you know, because we're typically dealing with small to intermediate sized data sets. Also a very unique feature within our platform. This is basically how the platform is laid out. Ultimately, you bring in your data sets, as you can see here, and data set 1 and data set 2. Preferably, your data set 1 should be some retrospective data set that's balanced, where you can actually build the initial models, as you can see in the blue in the middle, and you are training them and you're then testing them. And then the secondary, that data set 2, ends up being preferably your prospective data set, where you then are doing secondary testing. And all of these are happening simultaneously within the platform. So you're not basically going to different teams. It's a one-shot deal within the pipeline. So ultimately, you bring in the data sets. The MILO basically ends up seeing which features within the data sets are best for your needs and kind of takes care of the noise. And then you train the models, as you can see in the blue. And we don't make any assumptions about which algorithms are best. So we use 7 of the most commonly used algorithms out there, including our neural network and random forest, support vector machine, even some parametric algorithms like logistic regression and whatnot. And once that model is built within those algorithms, those supervised algorithms with the train test split and cross-validated 10 times, we don't stop there like many other platforms do. We actually want to have a secondary testing. And that's where the secondary test set comes into play, where all the models that were built in that blue area and that training phase and initial testing phase are then secondarily validated as well. That way you have 2 separate performance measures that you can look at. So like 2 separate ROCs that you can look at and see, oh, now the likelihood of having 2 high performing but nearly identical ROCs for the same model is going to be pretty small. That's how you minimize the overfitted approach product. And then if it serves your need and you're able to move on, then from there you can even deploy the model, as I'll show you in a second. So it achieves this because it builds hundreds of thousands of models, and through our proprietary approach is able to find the best hyperparameter feature selector set that ultimately gives you the best performing model for your given task. So it becomes very customized to your given study / your data set. Here's the quick demo on MILO, as you can see here. Here's the sepsis prediction model, as the burn sepsis one that I was basically showing you earlier. Ultimately, this is how it works. You bring in the data set, and everything in that grayed out area is automatically done by MILO in its MILO's pipeline. And so that initial data set, exactly what does it look like? It's just could be a simple Excel sheet, as you can see here. It's a CSV file, which basically is a flat sheet of Excel. So you just save your Excel sheet as a CSV file, which is a save as option within your Excel. And then you can see the stuff that were collected here were routine laboratory and clinical findings, along with some, certain scores, clinical scores. And then about half the patients had no sepsis in this case, so zeros, and half of them had sepsis, so ones. And then now loading up that data set into MILO is as simple as attaching a file into an email. So if you can attach a file into an email and email it to someone, you can work with MILO. MILO's platform is a very simple 4-step process, as you can see here. And that first step, which I'm showing you right now, that's when you load up your data sets, like the one that I just showed you. And loading it up is super simple. You just press the button and you attach that Excel file, and you puts a check mark next to it, says you're good to go. And if for some reason, if you brought in the wrong thing or it has missing things or weird things, it actually tells you and warns you and says, you got the wrong things. And that secondary data set, which I was telling you, in this case here, happened to be a prospective data set of about 204 cases. And about 80% of them had no sepsis, so zeros, and about 20% of them had sepsis, similar here. And again, loading them here is as simple as just clicking the button and attaching that secondary file in there, which is right here. And then you have to choose which target you're trying to map to. What's the outcome predictor here that you're trying to map to? So in this case here, we were trying to predict sepsis versus no sepsis. So the column where it says sepsis, that happens to be your main column. That's the one you pick, and now you're ready to go. And so in terms of how it works in real life, this quick little video shows you how it works. So you click on, as I showed you, and attach the training data. And then you put in your secondary testing data, as I showed you earlier. And then you attach the target of that you're trying to map to. And all the column headers automatically pop up. And the sepsis column, that was your target that pops up. And you go to the next step. That's step 2 now. And before you do any machine learning, we just want to see best gold standard for machine learning. Just see what is it that the data that you brought in is fully transparent. So you can see exactly what you brought in, see the basic univariate analysis here. And now if you're happy with the model, you can now go to the next step. Not the model, I mean with the process. And then this next step, this is the brain of it, where you're building all the pipelines. And by default, we actually recommend you running all the pipelines. That's the power of it, where you build hundreds of thousands of models, but it could also be customizable, as you can see here. So you can actually unselect certain things, so just so that it goes a little faster. And then now I can just press start training. And then it basically starts training by creating a wheel of pipelines. And this wheel of pipeline, the spoke, just to give you a dimension, the spoke of each spoke on the wheel represents an individual customized pipeline. And it's, as you can see, they're running different pipelines at the same time. So naive Bayes, logistic regression, neural network, random forest, all of them at the same time with different variations. And so that's how you're creating those few 100,000 models. Obviously, that's going to take a while. So a few hours later, when when all the pipelines have been built and all been assessed, now MILO automatically puts you into the 4th step. And in the 4th step, by default, it pops up the best performing model. And most of our users needed to see the highest sensitivity specificity average with the highest sensitivity. They're looking for screening tools, but you could pick whatever you want. It's a live table, so you can actually say, I want the highest ROC AUC. And whatever model that you pick there, or highest F1 and whatnot, and whatever model you pick there, it actually correlates with the graphs on top. And you can see it's fully transparent to see what you ran. So in this case here, you ran 129,000 models, exactly which, where, how many you brought in, how many you secondarily tested, what kind of cross-validation you've done. So now if you're happy with this and you're good to go, you notice that this model has 100% sensitivity and 85% specificity, but it's with 50% of the features, as you can see underneath that finger, the white glove. And so clinically, you may want to wonder what exactly those 50% are before you can actually start doing additional testing. So because we're fully transparent, you can now actually download that entire table with a lot more granularity and basically then study it further if you like. And so by just clicking that export button, you now have that full table with a lot more details on your desktop, and just open it up in Excel and start reviewing it. So you can redo the stats if you want. We give you the true positive, true negative, false positive, false negative. You can also see the 95% confidence interval and whatnot if you want to do p-value and whatnot. But in this case here, we wanted to see that same model that we had over there. What were those 50% selected features? Why did it remove 50% of the features and it's considered them as noise? So you can open up that column where it says selected features, and you notice the half that it picked are respiratory rate in the top row, respiratory rate, temperature, white cell, whatnot. That actually makes sense clinically too. So now I feel a lot better about the model, that it actually picked out something reasonable and realistic. So now instead of calling IT and actually going live, you can now just press the green button right there, and it fixes the model for you immediately, and you can actually start testing it immediately. It's a live model that can actually do the testing. So if I wanted to quickly test out, and so this is a model that has 100% sensitivity or a true positive rate. So if I put in somebody who should have sepsis in the burns unit and put in parameters that goes in tune with somebody who has sepsis, this model should catch them. And then once I manually enter them, or it could also be uploaded automatically through your LIS, because we give you the full script in there in terms of for you to upload files. And then so you can see right there, it predicted the thing as being positive with 62% probability. Now, so then that could be automatically uploaded within your LIS or within your information system, or it could be manually done, but maybe you may want to do a batch test. And for batch test, we just say, okay, fix the model so you don't have to retrain it all the time. And now forever, that model becomes yours, and naming it like best KNN sepsis, you now have the model to use forever. And now that same model, you now can use either individually or now as a batch mode. And so as a batch mode, I may want to quickly check and see how well it did on that secondary test set. And within a second or two, it gives you the answer of how well it predicted on that secondary test set as a separate Excel file. And now you can see that. And in the last two columns gives you the prediction of those 204 cases. So you can see negatives, zeros, and the probability for each one. So some of those are incorrectly called positive. So there are some false positives. So as an investigator, you can actually dig in and learn more about your study and about your data set. Obviously, got all the true positives correctly. Again, lots more to do. There's lots of additional stuff that Milo can do and a lot more tools to learn from. We have a full user guide with a lot more details that are online, and feel free to actually look at that for those further details on, for the Milo Pro. And with that being said, in summary, it's a super easy platform to use. It requires no machine learning expertise whatsoever, no programming or software engineering expertise. It's basically your personal machine learning and software engineering expert team at your fingertips. And most importantly, it follows machine learning study best practices, does it much, much faster than the traditional approaches. And by far the most important thing is that it's a validated platform with lots of publications to its name. So we have many customers and collaborators now who are basically working with us. And with that being said, I thank you for your attention, and please feel free to visit the site for more details. Thank you so much.